So the second part of indicator 10 is multiplying and dividing monomials. And the learning target, I can use the laws of exponents to multiply and divide monomials with common basis. So the vocabulary that you are going to be learning is monomial, product of powers property, quotient of powers property, and terms. Okay, so we'll go into that, but let's first begin with what is a monomial. Okay, so look at these terms that I have written up here. Some of them are monomials and some are not monomials. Okay, so I'm going to put a check mark against the ones that are monomials. Okay, um, so let's look at this one. Is X a monomial? Yes. Is AD a monomial? Yes. Is X plus 5 a monomial? No. Is X squared minus Y squared a monomial? No. Is 8X a monomial? Yes. Is X plus 3 a monomial? No. Is 6Y squared a monomial? Yes. So look at all the terms over here that I have put a check mark against. And so basically, what is it? A monomial is a number, a variable, or a product of a number and one or more variables. Okay, so it can be a variable, it can be a number, and a product of a number and variables. Okay, now if I look at, so 6y squared, it's a monomial since it is a product of 6 and y squared. Okay, the expression x plus 3 here, this is not a monomial because it is a sum of two monomials. Okay, so this is a sum, this is a product, and the product is what makes it a monomial of a number and a variable. The sum is going to separate it into different terms, but the sum or the difference is going to separate it into terms, but then these are not monomials. Okay, um, a monomial can only have one term, only one term. Okay, so the expression x plus 3 is a sum of two monomials and therefore not a monomial itself because it has two terms. Okay, so let's talk about the product of power property. Okay, the product of power property. So So I'm just writing the examples over here. The monomial is 6y squared, 8x, 80, x. These are all monomials. Okay, so there, you can see that. All right. So now let's talk about the product of powers. So let's say I give you 4 squared times 4 cubed. Okay, so let's look at these two. I have 4 squared and I have 4 cubed. So basically, what does that mean? That means that I have two factors of 4 because squared, 4 times 4, right? And then, so this is the first one. So this is the first one, 4 times 4. So I have how much over here? I have my two factors, right? Two factors, and then I have 4 cubed, which is times 4 times 4 times 4. Okay, so I have how many factors here? I have 3 factors here. Okay, so I have 3 factors over here. So when I look at this overall, how many factors of 4 do I have in all? Okay, so 2 plus the 3, you see that? I have total of how many? 5 factors of 4. Okay, so I just wanted to show you um, this way. So we have 2 factors of 4 over here. Write that properly. Okay, 3 factors of 4 over here. And overall, what do I have? I have 5 factors of 4. So there are 5 common factors all together. So the product is going to be of this is going to be, look, 5 factors. So it's going to be 4 to the 5th power. And how did we get that? Notice that the sum of the exponents of the original powers is the exponent in the final product, right? So basically, what am I doing? I am taking 4 squared and I am adding the the cubed over here because they have the same base, which is 4. And so what is 2 plus 3? I am going to get 4 to the 5th power. Look, 5 factors. All right. So you can multiply powers with the same base by adding the exponents. So when I have the same base, I have 4 and I have 4 is the same base. So all I do is I take the exponents and then I just add them up. So then I get 4 to the 5th power. Okay. And you can simplify a product of powers with like bases using the product of powers property. So this is the product of powers property. Okay, so I'm just going to write the example. This one is using the product of powers property. That basically means what? I've said 4 squared times 4 cubed. The bases are exactly the same, right? So because the bases are the same, all I'm doing is what? 4, and I'm adding the exponents, and I get 4 to the 5th power. So this is my product of powers property. All right. Now, um, let's quickly discuss when simplifying a product of powers using the product of powers property, like we are seeing over here, why do the bases have to be the same? For example, why can't you use the product of powers property to simplify x cubed times y squared? Okay, so in this case, please remember you can add the exponents when simplifying a product of powers with like bases, since you are determining the total amount of times a factor is used. Okay, I mean, if I had 4 squared times 5 cubed, a 5 cubed is different from 4 squared. The bases are not the same. All right, but if I have the same base, I'm basically seeing how many times is the factor being used. If the factors are different, you cannot add the exponents. You can't use the product of powers property to simplify 4 squared times 5 cubed. Those have totally different bases, or x cubed times y squared, because x and y are different factors. All right, so let's do a quick example. Let's say I give you 5 to the 4th power, okay, times 5. So in this case, we are going to look at the product of powers property to help us simplify this. So I have 5 to the 4th power times 5 to the 1st. So this is going to be what? There is nothing there. So that means how many 5s do I have? I have 1, right? So this is actually 5 to the 4th power times 5 to the 1st power. And now all I'm doing is I'm going to use the product of powers property. And because the bases are the same, which is 5, I'm going to take 5 and I'm going to add the exponents. And I end up with 5. 4 plus 1 is 5 to the 5th power. So this is the exponential form. And if I was simplifying this, what am I going to do? This basically means what? How many times is the factor 5 repeated? 5 times. 2, 3, 4, 5. And when I multiply this, I am going to get 3,125 in standard form. Okay, so 3,125 in standard form. So 5 to the fourth power times 5 is equal to 5 to the fifth power as an exponent. Okay, let's talk about another example like this. And let's do this expression. I'm going to write it over here. All right. So let's say I give you a problem, 9 cubed times 9 squared. All right. So first we look at, looking at the power, the product of powers property. I know that the bases are the same, which is 9. So all I'm doing is I'm taking the 9 and I'm going to add the exponent, 3 plus 2. All right. And so I get, what is 3 plus 2? 5. So 9 to the fifth power is my exponential form. And if I had to expand this or put it into the standard form, the expanded form would be 9 times 9 times 9 times 9 times 9. 1, 2, 3, 4, 5. Okay, and if I multiply this in standard form, I'm going to get 59,049, and that would be my standard form of this number, okay, of these monomials. So let's talk about multiplying algebraic powers. So if I have c cubed, to get a better marker, okay, let's say I have c cubed, all right, times c to the fifth power. So first and foremost, how will the product of powers property help you simplify this expression? So we are first going to obviously look at, do we have common bases? And what is the base here? So the base is c. So this is c and this is c, right? So how many c's do we have here? 3. How many over here? So there are 3 factors of c, and then there are 5 factors of c. How many factors of c overall? So based on the product of powers property, I take the same base and then I add the exponents. 3 plus 5, I'm going to get 8. So this is c to the 8th power. And that is my final answer. So you can do it based on the algebraic expression method also. Okay, let me do another one. Let's say I give you, let me write it over here. Okay, so let's say I give you a cubed times a to the fourth power. So once again, we look at, do we have a common base? And yes, the common base is a. All right, this is the same. So a, add the exponents, 3 plus 4. So I'm going to get a to the 7th power. Okay, and that is my final answer in that case. Okay, so let's now multiply monomials. And let's say I have a question in which I have negative 3x squared, negative 3x squared, all right, times 4x to the 5th power, 4x to the 5th power. Okay, now when you multiply the two monomials, let's see what we need to do with the coefficients. Okay, and the coefficient is what? The coefficient is the number that comes right before the variable. So here's my coefficient and here's my coefficient. Okay, and the variables are the x squared and the x to the fifth power. So um, what we are going to do, I'm just going to separate out the entire thing so you can see what is happening over here, because we are multiplying monomials. So this is -3 times x squared times 4 times x to the fifth power. So basically all that we're doing, we are multiplying all this. So we are now going to use the commutative and the associative property of multiplication. And then I am going to group the like terms. I am going to group the coefficients together and I am going to group the variables together. Okay, so I'm going to do -3 times 4. Okay, and then I am going to do the variables, which is x squared times x to the fifth power. So I'm going to write it out like this so that you can see what I'm doing. Now if I do negative times positive, I know that opposite signs gives me a negative product. So -3 times +4 is going to give me -12. Okay, so this is -12. And then I am going to use the product of powers property, and I am going to do x squared, because the bases are the same. I can add the exponents. So 2 plus 5. And so then I end up with -12. And what is 2 plus 5? That is 7. So -12 x to the seventh power is my final answer when I simplify. Okay, so whenever we are multiplying monomials with coefficients, please multiply the coefficients, and then if the bases are the same, we are multiplying, we are adding the exponents in the bases. Okay, now when simplifying the expression, why were the coefficients multiplied but the exponents were added? So please remember, a coefficient is the number used to multiply a variable. So a -3x squared times 4x to the fifth power, this, what does this actually mean? Okay, that means this part. It means we are multiplying all of this. Okay, and then the coefficients can then be multiplied using the commutative associative properties of multiplication, and the exponents are added because x is used as a factor 2 times in the first monomial and 5 times as a factor in the second monomial. Therefore x is used as a factor a total of 7 times. Okay, so that's why we are adding that part. So let's do another quick example of multiplying a monomial. Let's simplify negative 2m. So if I have -2m times -8m to the fifth power. Okay, so again, what does this mean? It means -2 times m times -8 times m to the fifth power. This is what it means. And I'm going to separate the coefficients, the -2 and the -8. -2 times -8, and I am going to separate the monomial, the variable part. So I have m, that means how many m's do I have? This is m times m to the fifth power. And when this basically means I have 1m. I have 1m, right? And so negative times negative is going to give me positive. So -2 times -8 gives me 16. And then I look at, I have the common base, which is m. and I have 1 plus 5, okay, which is my exponent using the product of powers property, and I get 16m. 1 plus 5 is 6 to the 6th power. So 16m to the 6th power is my answer in this case, right? Let's now talk about the quotient of powers. So we're going to talk about the quotient of powers property. So now we get to this part. All right, so the quotient of powers property, let's say we want to, I'm going to give you an example. Let's say I want to simplify 3 to the 6th power over 3 squared. Okay, so the first step I wanted to show you is we can see that 3 to the 6th power is a product of how many factors? 6 factors, right? Because this means what? 1, 2, 3, 4, 5, 6. How many factors of 6 do I have? Of 3 do I have? Okay, so I have 6 factors of 3. 6 factors of 3. Okay, and then let's look at 3 squared. And we know that the fraction line means what? Division, right? So that's what we are working on. So 3 squared means 3 times 3. How many factors do I have here? I have 2 factors of 3. I have 2 factors of 3. Okay, now we know that when we are dividing, we can simplify anything from the numerator to the denominator. So 1 3, another 3, 1 3, another 3. Look, so I've removed 2 3's from the top and 2 3's from the bottom, and then what am I left with? I am left with 1 2 3 4. 3 times 3 times 3 times 3 over 1. So ultimately, what do I have? I have 3 to the 4th power because 1, 2, 3, 4, right? There are 4 factors of 3 that is left. So 4 factors of 3 remain in the numerator and then 1 in the denominator. So the quotient is 3 to the 4th power. Notice that the difference of the exponents of the original powers is the exponent in the final quotient. So when I'm having division, this is what it basically means. If I have 3 to the 6th power over 3 squared, all right, what is going on? I can see that the common factor is 3, and I have taken the exponents and I have subtracted because I got 3 to the 4th power. So 3, we have 6 factors minus the 2 factors. What do I end up with? I end up with 3 to the 4th power. Okay, so you can divide powers with the same base by subtracting the exponents. So in multiplication in the same base, what are we doing? We are adding the exponents. In division with the same base, we are subtracting the exponents. And you can simplify a quotient of powers with like bases using the quotient of powers property. So this is called the quotient of powers property, and I'm going to write that over here so that you can continue to look at our vocabulary. So this one here, 3 to the 6th power over 3 squared. Like in multiplication, we added the exponent. In division, we are subtracting the exponents. And I end up with 3 to the 4th power. So as long as the bases are the same in division, the quotient of powers property says that you subtract the exponents. Okay, so let's do again, when simplifying a quotient of powers using the quotient of powers property, why do the bases have to be the same? Why, like for example, why can't I use the quotient of power property to simplify x to the eighth power divided by y cubed? Because once again, you can subtract the exponents when simplifying a quotient of powers with like bases, since you're determining the number of factors left after dividing out common factors. If the factors are different, you cannot subtract the exponents. You can't divide out any common factors in the expression x to the eighth power over y cubed, since x and y are not the same. So it's got to be the common base. So let's do an example. So if I give you x to the eighth power over x squared, let's see how we can use the quotient of powers property to help us simplify this expression. So all we're going to do, the quotient of powers property says when the bases are the same, you are going to take that same base and then we are going to subtract the exponents, which is 8 minus 2. Okay, 8 minus 2. Uh, 8 minus 2, so that gives me what? X to the sixth power is my answer. All right. Let's do another quick example. If I say x to the 10th power over x cubed, are the bases the same? Yes, they are both x. So I am going to do x, and based on the quotient of powers property, I am going to subtract the exponents. What is 10 minus 3 is 7. So this is x to the 7th power. And that is my final answer. Um, let's do one problem. Let's say Hawaii, we're going to divide powers. I'm going to give you a question about real life. So let's say Hawaii's total shoreline is about 2 to the 10th power miles long. Okay. And New Hampshire's shoreline is about 2 to the 7th power miles long. About how many times longer? How many times longer? Okay, times longer is Hawaii's shoreline than New Hampshire's. Okay, so in this case, of course, because it's asking times longer, what do we need to do? We need to divide. Okay, so 2 to the 10th power divided by 2 to the 7th power. And then we are looking at, okay, are the bases the same? Yes, both the bases are 2. So I just take the common base and I am going to use the quotient of powers property and I am going to subtract the exponent. 10 minus 7, that gives me 3. So this is 2 cubed. And if I'm writing the expanded form of this exponential form, this is 2 times 2 times 2. That is 2 is repeated as a factor 3 times. And 2 times 2 is 4. And 4 times 2 is 8. Okay. So this just tells me that Hawaii shoreline is about 8 times longer than New Hampshire's shoreline. Okay. Um, Let's do one with numerical powers. And So if I give you a problem, 2 to the fifth power times 3 to the fifth power times 5 squared, okay? And if I have to divide this by 2 squared times 3 to the fourth power times 5. So let's say I have this. Now we are again going to group the factors to use the quotient of powers property. Okay, so I've got to group the factors. The bases 2, 3, and 5 are not the same. So I just can't just start, using the 5 with the 3 or the 3 with the 2. I've got to group the common bases. So in the numerator and denominator, the common base is 2 here, 3, and 5 with 5. All right. So I'm going to group by common bases, and I'm just going to write it like this just so that you can see the common bases. I have 2 to the fifth power over 2 squared. So this is a common one. And then I have, you can put the dot in the middle, or even if I just write it like this basically means multiplication. So I have 3 to the fifth power over 3 to the fourth power. As you can see, at the 3 and 3 are the common bases. And then I have 5 squared over 5 because 5 is the common base. Now I'm going to use the quotient of powers property in order to simplify this. So here, common base is 2, and I have my exponents. I'm going to subtract the exponent, which is 5 minus 2. All right, times common base is 3, exponents 5 minus 4, times 5 is the common base, exponent 2 minus 1. When only 5 is written, that means the exponent is 1. And when I simplify this, I am going to get, I'm just going to do this here. Okay, so 2, what is 5 minus 2? I get 3. Times 3 and 5 minus 4, I just get 1, right? Times 5 and 2 minus 1 gives me 1. So this basically means 2 cubed times 3 times 5. And then when I simplify this, what is 2 times 2? 4 times 2, 8. So this is 8 times 3 times 5. And I know that if I do compatible numbers, 8 times 5 is 40, and 40 times 3 gives me 120. So I'm going to simplify it, and I end up with my answer as 120. So remember to just group the common bases together. And why is it important to group terms by their common basis? Because the quotient of powers property can only be used to subtract the exponents when the bases are the same. When the bases are the same. Okay? So let's talk about which expression. We are just going to convert this into an expression which is showing the simplified form. So I'm going to go ahead and do another problem. And I am just going to show you the simplified expression of this. All right. So if I say 5 to the sixth power times 7 to the fourth power times 8 cubed, and if I divide this by 5 to the fourth power times 7 squared times 8 squared. All right. So let's look at this again. What are the common bases? the 5 and the 5, the 7 and the 7, and the 8 and the 8. Okay, so I am going to use again the quotient of powers property, and I am just going to group the like bases, and then I'm going to subtract the exponents. So here, 5, 6 minus 4 times 7, 4 minus 2 times 8, 3 minus 2. Okay, and so what is 6 minus 4? I get 5 squared times. What is 4 minus 2 is squared. And then what is 3 minus 2 is 8. So this is the simplified version. And then of course we can calculate to solve. But I just wanted to show you how to use that product of the quotient of powers property. Now, another one, dividing monomials. Let's say we have 12w to the fifth power. So 12w to the fifth power divided by 2w. 2w. Okay. So in order to begin solving the problem, we are going to look at a couple of things. All right. We're going to look at the coefficients, and then we are going to look at the common basis. So I am going to just separate it out so that you can see the coefficient over here is 12. The coefficient over here is 2. So I can do this. 12 divided by 2. And then I can do the common base is W this way. All right. So when I divide 12 by 2, what do I get? I get 6. And then I'm going to use the quotient of powers property. And that basically tells me that my same base, which is W, and then I subtract the exponents, which is 5 minus 1. And when I do 5 minus 1, I'm going to get 6w to the fourth power. Okay, 6w to the fourth power. So, why are the coefficients divided but the exponents subtracted? Again, please remember, when the associative property is used to group the coefficients separately from the variables, a fraction can be created with the coefficients. Remember, a fraction bar means what? It just means division. And the exponents on the variables are subtracted using the quotient of powers property. And I'm going to just go ahead and do one last example with you. Okay, so let's say I have a problem 15y to the 12th power divided by 5y to the fourth power. So if I look at this straight up, I can look at the coefficients and I can simplify 15 by 5. How many times 5 is 15? 3. So this becomes 1 and this becomes 3, right? And then I use the quotient of powers property, which is 3y12 minus 4. Since it's division, we are going to subtract the power, the exponent over here. And so I get 3y12 minus 4 is 8. So 3y to the 8th power is my final answer. Okay. So once again, multiplying and dividing monomials is very simple. Just have to remember that you've got to have common bases. And if you are multiplying, you are going to add the exponent. If you are dividing, you are going to with the same basis, then all you're going to do is subtract the exponential part. And terms are nothing but you have monomials which are separated by addition or subtraction, and that's what causes the different terms, like 3x plus 4y, it's not a monomial. Those are two different terms because the addition or subtraction is in the middle. All right. So hope that makes sense, and you all have a wonderful day.